Hello friends, I am Dr.V Pandey, Head Department of Physics, Shivaji Arts, Commerce and Science College, Kannada. Now, today we discuss about the cyclotron. A cyclotron is a device to produce high speed ions. It was developed by Lawrence in 1932. The cyclotron is modified from form of a linear resonance accelerator. Now, construction of the cyclotron. A cyclotron consists of a hollow cylinder divided into two sections, A and B. Each section is known as Ds or capital D because of their shape. These hollow sections A and B have their diametric edges parallel and slightly separated from each other as shown in figure. The Ds are connected to high frequency alternating potential. The frequency is of the order of some megahertz and the potential difference is of the order of in kilohertz. These are enclosed within a large metal box containing a gas at low pressure and are insulated from the box. Then the apparatus is placed between the poles pieces of the strong electromagnet which provides a uniform magnetic field perpendicular to the plane of the disc. The source of ion is located at the midpoint of gap between these. These are the two Ds, one is A, another is B, and positive ions are inserted in these Ds. When a positive ion with a charge Q is emitted from the source, it is accelerated towards the Ds having negative. Suppose this ion is positive. First time, suppose consider that A is negative and B is positive. Then this positive ion is accelerated towards A and suddenly A becomes negative, positive and B becomes negative. So these ions can be accelerated towards B like this. And the motion of these ions is like this and this can be incident on a target. It is accelerated towards the Ds having negative potential as uniform magnetic field H is at right angles to plane of the Ds. The ion is forced to move along the semicircular path inside the Ds and comes back to the space between two Ds. The frequency of oscillator is adjusted such that the time taken to describe the semicircle by the ions is equal to the half of the period. If initially it has moved in the Ds A, after a half cycle Ds B becomes negative. As soon as the ions reaches the gap between the Ds, hence ions gets accelerated towards Ds B and moves along a semicircular path under the action of uniform magnetic field. In Ds B, the ion moves faster and along a circle of radius r1. Suppose in dA the ion moves along a circular path of radius r1. Here the required centripetal force for circular motion is provided by Lorentz force. HQV1 is equal to mv1 square by r1, where m is the mass of the ion, v1 is the velocity, h is the strength of magnetic field, and q is charge on the ions. Hence, the radius of circular path is r1 is equal to mv1 by hq. The time required to move along a semicircular path t is equal to pi r1 by v1. Substitute this value, we get t is equal to pi m upon hq. In the disc B, the ion describes a circular radius r2 and its velocity is v2, where r2 is greater than r1 and v2 is greater than v1. hq v2 is equal to mv2 square by r2 square, or r2 is equal to mv2 by hq. The time required to move in dB along the semicircular path t is equal to pi r2 upon v2. Substituting the values of r2 from equation 2, we get t is equal to pi m upon hq. Therefore, the time taken in each d is the same, but the speed of ions goes on increasing with increasing in the radius when it moves from one disk to the other. Thus the ion reaches each time in the gap just at the instant the other disk has become negative and will accelerate it further. This means the path of ion in the cyclotron is spiral with increasing radius. Eventually, the ions reach the periphery of the D, where they can brought out of the chamber by means of deflecting plate charged to a high negative potential. The positive ions are drawn out from the spiral path by attractive force and they can be used to bombard target. Now advantages. With the help of cyclotron, proton, deuterons and alpha particles possessing very high energy have been produced. The particles coming out of the cyclotron have energy of the order of million electron volt. The main advantages of cyclotron is that it is comparatively a low voltage source for producing high energy particles. Now limitations. The energy to which a particle can accelerate in cyclotron is limited by the relativistic increase of mass of ion with velocity. Now this is mass which is given by m0 upon under root 1 minus v square upon c square, where m0 is the rest mass, v is the velocity of the particle and c is the velocity of light. The time taken to complete one half is t is equal to pi m upon hq. Therefore, the time taken to complete one cycle t is equal to 2 pi m upon hq. Therefore, the frequency n is equal to 1 upon t, which is equal to hq upon twice pi m. N is equal to hq under root of 1 minus v square upon c square upon twice pi. Instead of m, it is m0. Therefore, the frequency of the ion decreases with increase in velocity. Due to this relativistic limitation, the ion takes a longer time to complete its semicircular path than the time decided by oscillator. Hence, the ion lag in phase behind the voltage applied to the Ds, and finally they are not accelerated further. The cyclotron operates successfully only with heavy particles and cannot be used to accelerate electrons.